Welcome to Cirrus Design. Our mission is to enhance the pure enjoyment of flying while expanding the personal aviation industry through innovative design and playing a leadership role in safety. Not just for those who choose to fly our aircraft, but also for you as a first responder. Here's Cirrus co-founder Dale Klapmeyer.
We're committed to safety here, and the commitment is beyond our airplane. We're committed to safety in the industry. Safety for all the airplanes, safety for the people that are flying, for the people who are using the airplane, safety for those people that are around airplanes.
Today we're going to take a closer look at two things you may encounter at an accident site. A ballistic parachute system, ours is called a CAPS, or Cirrus Airframe Parachute System, and the AAIR, or MSAFE Aircraft Inflatable Restraint. While both are designed to save people's lives in the event of an in-flight emergency or an accident, some of these systems' components could pose a serious threat to you as a first responder unless you know what to look for. First, let's talk about the ballistic parachute system. It's a mechanical device that deploys a parachute to lower an aircraft and its occupant safely to the ground in case of an emergency, such as a mid-air collision, engine failure, or loss of control. Meet Mike Busch. Mike has devoted countless hours and has traveled around the world to get the word out about first responder safety when dealing with ballistic parachute systems.
We're doing this because we don't want accident investigators, first responders, or anyone else who goes to an aircraft accident site to be injured in any way by any of these devices. I think the big thing is that a lot of these airplanes are older airplanes, not originally fitted with these systems, that now can be retrofitted. And so a first responder or an accident investigator goes out on site, he's not sure whether this has one or not. It's kind of one of those uneasy things.
It's important to understand how a CAPS or similar parachute system works. In case of emergency, the pilot activates the system by pulling a red T handle. This action pulls a stainless steel cable which activates an igniter at the base of the rocket. The rocket ignites, pushes the compartment cover aside, and pulls the parachute package away from the aircraft at speeds in excess of 155 miles per hour. The 55-foot diameter round parachute canopy then inflates automatically and lowers the aircraft to the ground. There are two pyrotechnical devices that are used to operate most ballistic parachute systems: a rocket and an igniter.
This red canister here, which some people think looks like a hydraulic cylinder, is the rocket motor itself. This is what's doing all the work and what's pulling out that parachute, that 55 pounds right here. Now this is a solid fuel rocket, so in this rocket motor, and I'll take the exhaust nozzle out of here, this is the nozzle. It's filled with solid fuel right in here. And you're dealing with a pound or so of fuel, maybe a little over. That's 1.2 seconds to 1.5 second burn time. That's all it has to do its job. Get it out there quickly, get the parachute open.
In addition, CAPS uses two reefing line cutters to re-rig the parachute straps once the parachute has deployed. Once the system has been fully deployed, the pyrotechnical devices are inert and pose no hazards to first responders. The time to be concerned is when the system has not been activated and the aircraft has crashed or is burning on the ground. It is at this time that the components may still be in the aircraft and can pose a burning or launching hazard.
In an accident where the chute is not deployed, it can become a real safety hazard to emergency responders. It's kind of like firearms. We always assume that a gun is loaded. And with the advent of the ballistic recovery system and airbag system, we really need to start stepping back and looking at all these aircraft as if they're loaded.
When an airplane crashes, it belongs to the National Transportation Safety Board. They are the investigative agency that is responsible for that aircraft. They are going to try and get commitment from other agencies and other companies to help support that accident investigation. The agency that they're going to be calling on next is the Federal Aviation Administration. They're the ones that are going to respond out of the field offices, send their investigators to help assist the National Transportation Safety Board members that are responsible.
As a first responder, there are some important things to remember when you encounter a crash site. First, for everyone's safety, make sure the aircraft's engine is shut down. The best way to shut down an aircraft engine is to stop the fuel flow to the engine. Access the cockpit and locate the red fuel control. Pull the control aft to the idle cutoff position. Most fuel controls are red and have star-shaped handles. Others may resemble a large cabinet door pull. You can also move the fuel selector valve handle to the off position. The fuel selector is usually located near the center of the instrument panel, in the center console, or on the left side of the aircraft's fuselage near the pilot's seat. Once the engine is shut down, turn off the aircraft's electrical power. Locate the master switches on or below the instrument panel, above the left cabin window, or below the pilot's left side window, and make sure the switches are in the off position. If the aircraft has a key in the ignition switch, turn the key to the off position and remove the key. If the aircraft is intact and there is no fire, the cabin can be locked for security. Give the key to the accident investigators when they arrive. Be aware of fuel, oxygen, and TKS tanks. Most aircraft carry fuel in their wings or in separate header tanks located above and aft of the aircraft's engine. Some have auxiliary tanks at the wingtips. Aircraft which are being flown long distances may have auxiliary fuel tanks installed in the cabin or baggage compartment. Many of today's general aviation high-performance aircraft have TKS fluid on board to de-ice the aircraft's flying surfaces. TKS fluid is generally stored in a dedicated tank, but aircraft operators have been known to carry auxiliary containers of TKS in places like the baggage compartment or in the backseat of the aircraft. Similarly, GA aircraft that routinely fly at high altitudes may be carrying portable supplemental oxygen bottles on board. Oxygen, like TKS fluid, can present a hot spot in an aircraft fire. Be on the lookout for composite hazards. Many of today's aircraft are made of composite materials and foams that can produce toxic or poisonous gases if they burn. The accident site should be approached from upwind while wearing an oxygen breathing apparatus or an organic vapor mask. Burned composite surfaces may disintegrate to the touch and may not support your weight. Extra care should be taken to protect yourself from composite dust, sharp needles, and shards of composite materials in the aircraft wreckage. Treat composite cuts or abrasions immediately. Locate and identify all components of the CAPS or ballistic parachute system. Look for the rocket canister as well as the igniter assembly. The rocket canister is a red canister about the size of a 16-ounce beverage can. When you locate system components, always consider them as live ordnance. Don't handle them, and keep heat or flame away from them if possible. Mark the components to remind other first responders to stay away from them, and call the Cirrus hotline at 800-279-4322 immediately. Air safety personnel at Cirrus can help you determine what risks are present and will send trained accident personnel to assist you with disarming any and all safety systems in the aircraft or wreckage. While searching for these components, stay clear of the rocket's potential flight path, which is aft of the rear of the aircraft. The area after the rear cabin window is where the rocket is stowed on Cirrus aircraft, so rescue personnel should approach the aircraft from the front or sides. The rocket exits the compartment at about 155 miles per hour and poses a significant impact hazard to personnel for the first 60 feet of travel. Most of the rocket's energy is spent within the first 100 feet of travel. However, inertia could cause untethered components to travel up to 10,000 feet in 1.2 seconds. An emergency locator transmitter, ELT, is required equipment for all certified general aviation aircraft. ELTs automatically transmit a locator signal to the U.S. Air Force search and rescue facilities if the aircraft experiences a sudden impact. You may be asked to locate and turn off an ELT at an aircraft accident site. On the Cirrus and most recent production aircraft, an ELT shutoff switch can be located on the instrument panel. If the ELT has been activated, a small red light next to the on-off switch may be flashing. Simply press the black button to switch the ELT off. Never cut into the top of the aircraft or the area from the top of the doors to the baggage compartment, as this is where the CAPS activation cable is located. If this cable is pulled or dislodged more than 1/4 of an inch by cutting or penetrating gear, the pull of the cable could set off the rocket igniter and deploy the rocket. If the CAPS system has been deployed during high wind conditions, the aircraft could be dragged downwind after it touches down, posing a hazard to personnel and objects on the ground. The best thing to do in this case is to collapse the large canopy by spraying it with water from a fire hose. Once it has collapsed, park a heavy vehicle on the canopy to stabilize the aircraft from further movement. The other potential hazard you may encounter involves the AAIR, or M-Safe Aircraft Inflatable Restraints. These restraints work like an airbag to protect aircraft occupants from injury to the head and body. On a 3-point system, the airbag itself is attached to the lap belt, while on the 4-point harnesses, the airbag is located inside the outboard shoulder harness. Both systems use a heavy leather shroud to protect the airbag itself. The danger in this system comes from the fact that it uses compressed helium to inflate the airbag. Like the CAPS system, you must always assume that the system is live unless you see that the airbags have been deployed. Cirrus works closely with the National Transportation Safety Board to maintain an accident investigation team that's ready to respond to any Cirrus aircraft accident 24 hours a day. Although each system's installation will differ slightly, all ballistic parachutes and M-Safe AAIR airbag systems will operate by the same principles and will use the same basic components. That's why it's important to know what to look for and how to react.
There is a system on board this airplane because this is the airplane that ballistic recovery system.
Here at the Transportation Safety Institute, we train all of the Federal Aviation Administration air safety investigators, and they're the ones that are going to be the first responders as far as the government's concerned on aircraft accident investigation. And we have an 8-day training course here, and we talk anything from engines to props to systems to airplane designs to ballistic parachutes. Anything that's new out there is what we touch on.
The importance of an investigator is to go out and find out what happened and then to prevent it. However, out on an accident site, the investigators need to know that there's a lot of things out here that can hurt us. And then you add additional things like the ballistic parachute system, where you've got an actual rocket that could go off in your face and hurt you. It's important that they understand that the tragedy's over with when the accident happens and that they shouldn't rush. They need to come out here and be very methodical and have a checklist, understand what they need to collect, and do the best job at doing that.
You never know what you're going to run to on a site. In my particular site, there was a ballistic recovery system which could be explosive and people could get hurt. And so it's important to have information, contact information, whether it's the aircraft or whoever's in charge of a ballistic recovery system, so that make sure everybody is safe.
So we have to change how we think about these things. We have to assume that it's got a system on board when we go out to an accident, rather than be surprised by when we find one. I think that's the key. And then what do you do? How do you deal with it? Who do you call? And of course you have to identify and notify. That's the policy. Identify that you have a rocket, and then call somebody that can help you. Cirrus will be glad to help you.
The next time you respond to an aircraft accident or fire, consider that the aircraft might be equipped with a ballistic parachute and AAIR restraints. Proceed accordingly by approaching from the upwind side. Identify and locate all components. Assume the systems are live unless visibly deployed. Keep heat and flame away from the site. Remember the no-cut zone on Cirrus Aircraft, and most importantly, contact the Cirrus Air Safety Department immediately. And finally, qualified personnel should remove all hazardous components from the aircraft wreckage before it's transported from the accident site to the salvage yard. We're committed to your safety, and we're here to help.